Hey, what's up guys? This is Andrew from Cascade Tutoring. Thanks for joining today. In today's video, we're going to talk about linear functions. I'm going to start this video by talking about all of the things that you're going to need to know for this section, the things that the SAT does not give you on the formula sheet. And then in the second section of this video, I'm going to talk about all of the tricks and tips that you can use to kind of breeze through some of the math parts of this. So let's get into it real quick. So the things that are going to be important for this section are knowing the different forms. So for example, everyone's familiar with y equals mx plus b. In y equals mx plus b, m is your slope, b is your y-intercept. This is called slope-intercept form. They will not give you this on your formula sheet, so make sure that you understand what this is and maybe make sure that you memorize this. The second form you're going to get is standard form. AX plus BX equals C, so this is standard form. And the third form that you're going to get or going to be asked to convert into is point slope forms. This is y minus y1 equals m x minus x1, where y1 and x1 are a point and m is your slope. So this is your point slope form. Now, there are going to be questions on the SAT. So these are level 1 questions where they're going to ask you to identify the slope in the y-intercept from a slope-intercept form. So they might give you something like this, y equals 2x minus 3. And they're going to say, what is your slope and what is your y-intercept? Well, in this case, your slope is your number, the constant right here, and your y-intercept is the number or constant right here. They're also going to give you lots of questions that say something to the effect of, Tessa gets a job over the summer, she gets a $200 signing bonus, and she makes $30 an hour. Write this in slope-intercept form. Okay, so Tessa's money is equal to whatever the slope is. And so remember that slope is always your rate, right? So whatever is changing over time, right? So for every hour that Tessa works, she makes $20. For every 2 hours that Tessa works, she makes $40. So your slope in this case is 20. I'm going to put T here for time, or it could have been H, whatever. And then what was the starting? I think I said that Tessa made a $200 signing bonus. So this is a level 1 question on the SAT. Okay, they're going to give you lots of these. These should be pretty quick. Make sure that you know that your y-intercept is always your starting point, and this is always your rate, the thing that is changing over time, right? So we could be using this in the context of like recipes. For every 2 cups of water, there's 3 cups of flour, right? For every 1 mile that someone runs, it took them 6 minutes, okay? Another type of question that you're going to see on the SAT is they're going to give you something in standard form. So they're going to give you something like this. And they're going to say something of like, what is the slope for this? Now, there's a couple different ways to do this. Let me run through the algebra real quick. I'm going to move through this fairly fast. If you need help with the algebra and the steps, make sure to go watch some of our other videos. So basically what we're asked to do here is isolate for y. Okay, so if I minus 2x on both sides, if I isolate for y, what I'm getting is this into slope-intercept form. So 3y equals negative 2x plus 13. Again, the negative 2x and 13 cannot go together. We're going to divide both sides by 3. So y is equal to negative 2 over 3x plus 13 thirds. So again, what this is asking is, what is the slope? Well, the slope is negative 2/3 x. Okay, so when we have something we don't know, just convert it into something we do know. Everyone's really familiar with this y equals mx plus b. Okay, the last one I'll talk about the long way is the point slope form. And again, this is a level 1 question. They're going to give you a slope. So they're going to say slope is equal to 5, and then they're going to give you this. Remember, our point slope form is this. The biggest part here is making sure that we memorize that there's negatives here. Now, this is a trick that you can't use with Desmos, so we want to make sure to memorize all three of these just in case we can't use Desmos. I will show you how to use Desmos here in a second. So, for example, they give you a slope and a point here, and they ask you to put it into point slope form. Well, we know that this is our x1 value, and that's our y1 value. So to put this in a point slope form, we say y minus y1. Well, y1 is -5. That's going to be a -5 equals m times x minus x1. Now, what's really tricky here, and we have to remember, is if we have two negatives, that always means positive. So our answer here is y plus 5 equals 3 times quantity x minus 3. Okay, so what I would encourage you to do is in this section, if you have to convert or solve and things like that, you can do that. But Desmos is going to be our friend. Okay, so let's walk through a couple different problems that we're going to see that we'd want to use Desmos for. So for example, in this situation where they give you 2 points. So like 0,3 and let's say 7,5. And they ask you to write this into slope-intercept form. Now, we could go through and do your y2 minus y1, x2 minus x1, and make sure that we're putting this into and then finding our y-intercept. That's totally fine. That's going to take us time. We only have 75 seconds per question. So here's the fast way to do it. So the fast way to do it is this. We want to write an equation for a line that passes through these 2 points. In Desmos, here's what I want you to do. On the top left-hand corner, push the plus button, and then I want you to go down to table. Okay, we're going to type in the points, 0, 3, and then 7, 5. Okay, once you type in at least 2 points or more, you can go into the top left-hand corner of Desmos in the table part here, and there's going to be that line with the dots. Now you're going to choose the type of regression model that we're going to use. In this case, we know it's a linear regression, right? Because they give us 2 lines and they tell us to put it into a linear form, which is y equals mx plus b. So if it asked us to put it into a quadratic regression or a cubic or something like that, which they probably wouldn't, you could do that. When you click linear regression, I'll zoom in here. They're going to ask something in the question of like, what is the slope or what is the equation for the line? This right here, right, what we see here is the equation for the line. If they asked what the slope was, the slope would be 0.286. Okay, so you see how fast that was, right? We could have done this by hand. It would have taken us a little bit of time. Or we could have said, well, let's just put it into the table and do the linear regression. All right, so the next type of question you're going to see on the SAT is, again, they're going to give you something in standard form, 3y equals 10. And they're going to say, what is your y-intercept of this? Now, again, you can do this by hand. You could go through, solve for your y, figure out what your b value is. Or we could come into Desmos and type this in and simply click on this. So what is our y-intercept here? Well, it's 3.33, okay? What is our slope here? Well, what we could do is we can remember that slope is rise over run. And so what I would do is I would pick 2 points that go through nice crosshairs. So it's hard to see. I'm clicking on the point right here. So the point 2, and then there's a nice point here, 5, 0. So the slope here is negative because it's going downhill. We're going to go down 1, 2 over 1, 2, 3. So the slope here is -2 over 3. Okay, so again, this would be a level 2 question. Now, the last type of question that they're going to give you is something about parallel and perpendicular lines. So let's go back here real quick. So we want to remind ourselves that parallel lines are lines that do not cross. Okay, parallel lines, if we have these, it means that, again, the lines will never ever cross. They will always move together. And the slope for parallel lines is always equal. Okay, so for example, if I was given this equation and it asks you to write an equation that is parallel to that one, you would say, well, equals the same slope and then a different y-intercept. If we had the same y-intercept, this would be the exact same line, and that would be infinite many solutions. Because this is parallel here, and we have a different y-intercept, this would be considered no solutions. So in other words, a systems of equations, they never cross. Perpendicular lines are different in that they do cross once at a right angle. Okay, so let's say, for example, we have the exact same line, and we wanted to write a line that was perpendicular to this. We would find the opposite slope. When I say opposite, I mean opposite from a sign perspective. So this one's positive, this one's negative. And then this is technically 2 over 1. So the perpendicular slope to this would be negative 1 over 2. Now, for perpendicular lines, it does not matter what the y-intercept is. So we could have the exact same y-intercept, or we could have a different y-intercept, and they would always be perpendicular. Going back to parallel lines, if we have the same y-intercept and the same slope, well, that's the same line. So therefore, we have the same line. That's not, that wouldn't be parallel because it's technically touching. So this one, if we're doing a system of equations, this would have one solution because it crosses exactly one time. So make sure that the big ideas here is